So, you know, when we write a program, we're usually keeping track of data, and the user is usually updating and reading and editing and creating new data. And when they get finished using our program, we have to store that data somewhere. Otherwise, all that data will be lost. So programs need to be persistent, and what that means is that they persist the data, meaning that when I close the program once, I can open it again later and all my data will still be there. So that's why, and what we do is we store this data on the file system. Okay, so we want to make our programs persistent by writing data to files and then reading data from files. And that's what we call a file I/O, or file input and output. Input means that we're reading data into our program, and output means that we're writing data out of our program. Okay, so how do we do this? Well, the answer is with streams. So in Java, there's all these classes that are called stream objects, and we can use these streams act as kind of a connection between our program and a file on the file system. Okay, so they're these virtual objects, or they're classes that we can use in Java that allow us to allow our program to connect to files. Okay, and I put a link in here for you to take a look at. This is a pretty comprehensive overview of file I/O in Java here. Okay, but this is a big topic because first of all, we've got some classes that represent input streams for reading into our program, and then we've got another set of classes that represent output streams for writing data out of our program onto the file system. And there's different kinds of streams. Whoops, I have a typo here that I'm just seeing. This should say streams here. There's different types of streams. So some of our streams write to files. Some of our streams might write to another computer. So there's different sorts of endpoints for what we're writing to. It's not always going to be a file. It could potentially be something like a database or a computer on the network somewhere. So we have to have streams that account for these different endpoints. We also have stream classes that allow us to work with primitive data types. We've got stream classes that allow us to work with text, and we've got stream classes that allow us to work with objects. So we'll see an object in action here. I've created a student class, and we'll create a bunch of student objects, and we can save all that data using a specific type of stream. So there's kind of an explosion of stream classes depending on what you want to do. Input streams, output streams. What kind of data are you working with? Are you working with primitive data types? Are you working with text? Are you working with objects? And there's classes that represent all this stuff in a stream class. Okay, so under the hood, everything has to be converted to a byte. Everything is a byte on our computer. So underneath the hood, everything's going to be a byte stream. But we also have stream classes that use byte streams and make it easy for us because we don't have to worry about working with bytes. We can just feed in text. For example, a text stream class. Well, actually, I don't know if there's a text stream class, but there are classes that allow us to work with text. There are stream classes that allow us to work with text. So my whole point here is that, as you can see, there's all sorts of different variations of streams, and on top of that, we kind of use these together in many cases. So if I want to convert text and save it to the file, what's really going on underneath the hood is that there's a byte stream. So there's a byte stream class that's being used by my text stream class, for example. I don't know if I explained that very well, but we often use these different types of stream classes together, and they kind of become adapters. Like an adapter would convert text to binary, or binary to text. So they're kind of like adapters. They do conversions for us. And to make it even more complicated, we have what are called buffers. So buffers are classes that deal with streams that allow our streams to be more efficient. So you'll see classes that have the name buffer in them too. So what it all boils down to is there's a whole bunch of different types of classes that we need to use in order to work with file I/O. Okay, so I created a class that does a lot of file I/O for us. It's called File Manager right here. Let's go ahead and open that up. double click it. There we go. I'm going to close this because we're done with that. Okay, so and by the way, this is actually an API. You can call a class that you write an API because it has an interface, and what I mean by that is it has a bunch of methods that I wrote in it. Okay, now a lot of times when you're working in Java, you're using different classes or APIs. By the way, APIs can mean a collection of classes. Usually, like an API is a whole package of classes. And a lot of times when we're using APIs, we don't actually get to see the Java code. What we get is the compiled code, and we can't see the code that's actually in all the methods. We can just call the methods, but we don't necessarily know what's going on. So anyways, I've given you the code here so we can take a look at the code inside this API that I wrote. So there's a whole bunch of comments here that I put at the beginning, and then around line 88 or so is when we see the first method. Okay, so let's go ahead and go back over to our app driver and scroll on down to step 2, and let's create an instance of this API that I created. So it's called File Manager. That's the data type, or that's the class name, and we'll give it a name of FM, and we'll call the constructor new File Manager. Okay, so there we go. That's step 2. Okay, so like I said, there's different types of streams for different things, and the first thing we're going to do is we're going to take an array of primitive data and store it to a file on the file system. So right here, let's create a byte array. So we'll make an array of bytes like that, and we'll call it BA for byte array equals, and then we can just put a bunch of numbers in there. Let's do 1, 2, 4, 6, whatever, 8, something like that. It doesn't really matter the data that you put in it. So this is an array of bytes, and I have a method in my API, my file manager API, called write binary. So we're going to go FM, that's our object, and then we're going to call the write binary method here, and look at it takes a couple of parameters. It takes a file path, so I have to give it a file path. And then it also takes our array that we're passing in, our byte array. So what I'm going to do is for the file path parameter, I'm going to enter in saved bytes like this, and then we'll call it dat. A lot of times when you save information, the file extension is called dat. Okay, and then the second parameter is going to be our byte array, which I call BA, like this, and I'll go ahead and save this now. Make sure you type this in just right. So that first parameter is a string, and that's going to be the file name that gets created to store this data. And I'll go ahead and save it and run the app. And we don't see anything happen here, but if you go and look, I'm going to refresh this here. If you right click on the project and do where's the refresh here, F5 like this, you'll see here's a file in our project called save bytes.dat. So this stores that byte array on the file system. So it created a new file for us. If I try and open that, it's just binary data, so you can't make much sense of it just from opening it. But there it is. So let's take a look at that method, write binary, in my API. Now we have this luxury because a lot of times we don't get to look at the code inside of the classes that we're using, but we have the code in this case. So here it is, public void write binary, and it takes a string, that's our file path, and it takes an array of bytes. Okay, now here's our try catch. Now I told you before that you can catch different types of errors. So and you do that by adding more catch blocks onto your try catch. Okay, so a lot going on here. We put our dangerous code in the try block. So here we're using an output stream. Remember, we're writing out of our program, so it's an output stream. And this is a stream that will write a file, but what we want to write out to it is primitive data. So if you want to write primitive data, you have to use a data output stream. So look at how this works. So we create a file output stream. So that's going to allow us to create a file or write out to a file, and then we call that FOS. And then we take that object, FOS, and we pass it into the constructor of this data output stream. So, and like I said, a data output stream is used for writing primary or primitive data to the file system. So remember how I said we kind of use these stream classes as adapters? Well, we're seeing it now. So we create a file output stream, and we pass that into our data output stream, and then the data output stream will write that primitive data, and then the file output stream will actually write it to a file. So on our data output stream, once we call the write method and pass in the data that we're trying to write, that does the trick right there. And then whenever you're working with a stream, you need to close it usually. So remember, a stream is kind of a connection between our program and the file system, and you should close. Call the close method when you're done using it. So we're going to close our output stream, and we're also going to close our file output stream here too. Now let's take a look at these catch blocks here. First of all, I'm looking for the possibility that the file is not found. But in this case, that won't happen because we're actually creating the file. But if I was trying to read in something, it's possible that I could maybe not find the file I'm looking for. Now, and then here's kind of a general input-output exception. And this would tell us that there was a problem with our input and output, and this would be the code that runs if we had a general I/O exception. And then here's kind of the catch-all right here, is any kind of exception. So we don't want to get too much into these catch blocks, but you'll see that you can have multiple catch blocks that will catch different types of errors depending on the error that actually occurs. Okay, let's go over to our app driver again, and let's save a text file in this case. So let's create a string variable here I'm on step 4 now, so we'll go string file path equals test1.txt, so that'll be the file that we're going to write to. And then I'll go fm, that's our file manager object, save text file. And the first parameter is going to be the file path, and I've already created a variable for that. And then I can actually pass in a string, and the second parameter will be what we save into that file. Okay, so I'm going to go ahead and save this and then run it, and we won't see any output here because we're not writing any output. But if I right click on my project and hit refresh here, we'll see here's another file, test1.txt. And if I open it up like this, I can see there's that string that I wrote to it. Okay, let's see, do we want to take a look at the code for that? Let's take a look at the code for that. So that's down here. I'm in the file manager class, and save text file. So the first parameter is the path, so that's going to be the path and the file name. And in this case, we're just writing to the same folder that our project is in, so we don't need a path, we just need a file name. If you just put a file name in, it'll put the file right in your project directory. Now here's a print writer. This is a file stream class, and it allows us to write text. So a print writer stream will handle text for us, and this one's a little bit simpler. This print writer class kind of encapsulates a couple of different classes underneath it, so it takes away the need for us to create these different streams. But I simply create a print writer, and then I call print line, and it'll write to it, and then I close it. And then here we've got our try catch here too. So that's the code for that. Okay, now you can take a look at the rest of the methods in here if you want. I'll just focus on what we're going to do in app driver. So now that we've saved a file to the file system, let's read a file from the file system. Let's actually read that file that we just wrote. So I'm going to go, let's see here, we're down on step 5. Okay, so I'll go over here on step 5. We'll go fm open text file. So if you look inside that file manager class, you'll see this method, and let's just put the file path in here, and we'll use the file path, the file path from before, that string variable that we used up here. So that's gonna, and then let's see what this does here. So I'm gonna save this and hit run, and there we go. So it's saying opening the text file, hello there. Let's just take a look at that real quick in the code here. So I go to the file manager class and I scroll down a little bit, and here it is, open text file. And now in this case it's using a file reader class, and this is a stream class for reading in files. And then what this for loop does is we're going to loop through so we've got this file reader object, and I've called it reader here. And one of the methods is that you can read line by line. Actually, I think this is character by character. So what we're doing here is we're reading every character in the file and then sysouting it. And that's what we have here. And then when that's all done, we're just write this little message down here too. So I don't know, this isn't very useful, but it demonstrates how we can read in a file from the file system. Okay, let's go back over to the app driver, and this video is getting a little bit long, so I'm going to try and speed up a little bit, but I don't want to, I know there's a lot to cover here. Okay, so let's see what happens if we try to open up a file that doesn't exist. So go down to step 6 here, and let's just use that same method that we tried before. So fm.openTextFile, and let's just enter some file.txt, and this file doesn't exist in our project folder. Let's just see what happens here. So is it going to crash my app? I'm going to hit Control S to save it and then run it again here, and look at that. So now this is, if we look at the code over here, what's happened here is it's this catch block that's running. So is it? Wait, is that the right one? Yeah. Okay, so yeah, it's this. It couldn't find the file we're looking for, so an error occurred in here when we tried to open that file. So it jumped to the catch block, and this is the result that we're seeing down here. Some file. This is the we call toString on that exception object here. So, but the nice thing is our app did not crash. It would continue to run code after that if we needed it to. Okay, I'm going to go ahead and comment this out since it. I wouldn't have to, but I'm going to go ahead and comment out step 6. So final couple of steps here. I think we'll just do step 7 and 8 and we'll be done. But what we can do is we can create an array of objects and save those too. So this is where we start getting into more practical stuff. So in our programs, we keep track of data, and we keep track of that data in objects usually. In my case, I'm going to be dealing with student objects. So I've got a if you look in the files here, you'll see that there's a student class and there's actually a department class. And if I open up the student class here, you'll see that it's got some instance variables, first name, last name, ID, and then it also has an instance variable for the department, and I actually created that data type too. So I created a department class, and that's over here. If you wanted to take a look at that, you could. But what I wanted to do this to show you that you can save these complex objects. So it's an object that has another type of object as an instance variable inside of it. So anyways, we need to create some students here. So let's go student S1 equals new student, and then for the constructor we can pass in a name, a first name, a last name, an ID, that's an int, so I won't use quotes around it, and then to pass in that department is an enum, so I can go department, and then they're in the business department, and I think that's all I need here. So there is one student. Let's create 3 students. So I'm just going to copy this line of code and paste it, and then do some updates here. S3, I'll change the names here. Smith, Doe, and let's go Sally over here. You can put in whatever you want. Tim, change the IDs. Let's put, what are the other departments that we have here? So we've got business and history, so just 2 departments. So I'll go history there. Okay, good enough. So I've got a couple of students, And then I'm going to go ahead and put these students in an array list. So as my program runs, we build up an array list of student data. So I'll go array list, and it's going to be data typed as student, and then we'll just call it list. That'll be the variable name, and we'll say equals new array list, like that. And then we'll go ahead and add to our list. We'll add S1. I'm going to copy that line of code, paste it 2 times, and I'll just change S1 to S2, and then this S1 I'll change that to S3. So now I've got an array list of students. Okay, so a lot of work there, but it's going to be worth it. So now we want to save this. So as our user is creating students, then it gets to be 5 o'clock and they need to clock out. So they're going to turn off their computer. So what we want to do is we want to save this data to the file system so that it'll be there when they come back to work tomorrow. So what we'll do here is we'll use our file manager class fm.saveObject, and we'll give it a path of students.dat, like that. And I think you could use any file extension that you wanted to, txt, but usually when it's objects or some sort of data, it uses .dat. And then we'll pass in our list here. Okay, so I'll save that, and then I'll run my program, and we won't see anything because there's no output. But if I refresh over here on the project, there is our students.dat. Let me open that up. So this is now this is stored as binary data or something that looks like it, so we can't really make much sense of it. So that's great. We just stored all of the data from our program on the file system. So now we have persistence. So that data is going to persist. So let's say we come back and we want to work with it the next day. So let's step down to step 8 here. So we'll go ahead and let's restore those students from the file. So let's do this. Let's go for step 8. We'll go, let's create an array list of students, and we'll call it, let's just call it new list, and then equals new array list, and that's be like this. Okay, now the way this the method that we're going to use is going to be called deserialize objects. Let's just take a look at that real quick over here in our file manager. So deserialize objects. See what that returns? It returns an array list, but the data type is object, not student. So what we need to do is we need to create another array list here that holds a data type of object. Let's just do that here. So let's go array list and data type it as object. And then what do I want to call this here? Let's just call it objects equals new array list, like that. And then I'm sorry, we can actually just call the function here. Let's go fm.deserialize objects. That's the method we want to use. And then it's asking for the file path. Well, the file path is going to be that student.dat file that's storing our student information. And then what we're going to do is we're going to loop through those objects. So we'll go for object O in objects, and we're going to convert each one to a student. So let's go student S equals O, but we're going to cast O from an object to a student like this. Okay, like that. And then let's add that to our new list. So we'll go new list dot add, and then we'll add the student there. So first we have to get out an array list of objects, and then we loop through those objects and turn each one into students. We cast it to a student. Now I could have made this method here return an array list of students, but I didn't do that because what if I want to use this method to deserialize other types of objects that I might have in my program, like employees or teachers or something like that. So that's why I made it return an array list of objects so that I could use it for other class types if I needed to. So now let's go ahead and just do, I think if I do a sys out on my new list, we'll see what we get here. So we'll go ahead and save that and then run it. This video is getting really long. Sorry about that. Okay, let's see what's going on here. Let me change something here. I'm gonna loop through this array list of students here. I'm gonna go for student S in new list, and then I'll do a sysout S, just like that, and we'll see what happens now. What am I missing here? I see my problem. I actually got an error here, and I caught the error in my code, but I am missing an S right here. So that's my problem. It's students.dat, not student. So now that should work here. There we go. So this demonstrated how you can save a bunch of data in your program to the file system and make it persist so that that data can be saved and brought back into the program later. So first we serialized the students. Serializing is a way of saying that you're saving objects, and then we deserialized those students, meaning that we pulled them from the file system and turned them back into student objects so that we can continue working with them. Okay, that will do it.